Welcome to this space class. In the previous class, we have studied how to find the volume of combination of solids. This section also we will continue with that. Consider this question. A juice seller was serving his customers using glasses as shown in the figure. The inner diameter of the cylindrical glass was 5 cm, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. If the height of a glass was 10 cm, find the apparent capacity of the glass and its actual capacity. In the previous section, we discussed about the apparent capacity and the actual capacity. So here, the inner diameter of the cylinder is given for you, or inner diameter of the cylindrical vessel. That is 5 cm, and height of the cylindrical glass is 10 cm. And a hemispherical portion will be in the base of the cylindrical glass. We want to find the apparent capacity and the actual capacity. So here apparent capacity is equal to the volume of the cylinder. The actual capacity means when you subtract the volume of this hemisphere, you will get the actual capacity of the cylinder. So the apparent capacity is equal, first of all you can write the diameter is equal to 5 cm. So radius is equal to 5 by 2 cm, and height of the cylinder is equal to 10 cm. So the apparent capacity of the glass is equal to volume of cylinder, that is pi r square h, that is equal to 22 by 7 into r square. R is equal to 5 by 2, therefore 5 by 2 into 5 by 2 into height, that is 10. You can cancel the common factors. Here 11 and 2 5s are 10. So you will get it 11 into 125 by 7, which is equal to 196.25 centimeter cube. So the apparent capacity of the glass is equal to 196.25 centimeter cube. But the actual capacity of the glass will be less than the volume of the hemisphere at the base of the glass. That is less by 2 by 3 pi r cube. So the actual capacity of the glass is equal to volume of cylinder. That means the apparent capacity of the glass. Apparent capacity of the glass, that will be equal to the volume of cylinder. So you can write apparent capacity, or you can write volume of cylinder. Volume of cylinder minus volume of hemisphere. Which is equal to pi r square h minus 2 by 3 pi r cube. Here already we find out the volume of cylinder, apparent capacity we already find out. So that we can substitute here 196.25 minus 2 by 3 pi, that is 22 by 7 into r cube. Here the radius of the hemisphere is equal to the radius of the cylinder. Both are same base. So that will be equal to 5 by 2 whole cube, that is 5 by 2 into 5 by 2 into 5 by 2. Or you can write the decimal form decimal form of 5 by 2. Now you can, if you are writing the fraction form, you can cancel the common factors. Here it is 11 times. So 196.25 minus 11 into 125 by 3 into 7 into 2, that is 42. When you solve this, we will get the actual capacity of the cylindrical glass. Let us see the next question. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 cm and its height is 180 cm. When the solid is placed upright in a cylinder, that time some amount of water will flows out. Now that cylinder full of water, the water in the cylindrical vessel, the amount or the volume of water in the cylindrical vessel is equal to the volume of cylinder. That time a solid, the shape of solid is a cone mounted on a hemisphere that is placed upright in a cylindrical vessel. When it is placed in the cylindrical vessel, the water, some amount of water will flows out because that is cylinder is full of water. When you kept something inside, the water will flows out. So the amount of water or the volume of water flows out, it will be equal to the volume of solid. How much water, the amount of water flows out, that will be equal to the volume of solid placed in a cylinder. So we want to find the volume of water now left in the cylinder. So volume of water left in the cylinder is equal to volume, total volume, that is volume of cylinder minus volume of this water flows out. That means the volume of this solid. So here it's given for you, the radius of hemisphere is given and the radius of cylinder is given, height of the cylinder is given and the height of the cone also given for you. When you observe the figure, you can see that the radius of cone and radius of hemisphere and radius of cylinder all are same. It is 60 centimeter because these three figures have the same base. And the height of the cylinder is equal to 180 centimeter. And height of the cone is equal to 120 centimeter. Height of cone 120 centimeter and the radius of hemisphere is 60. So the total length of the solid is 180 centimeter. That is same as the height of the cylinder. Now we want to find the volume of water. Volume of water in the cylindrical vessel. Which is equal to volume of cylinder. That means the total volume. Volume of water before keeping that solid in the cylinder, the volume of water in the cylindrical vessel is equal to the total volume, that is the volume of cylinder. That we can find out by using the formula pi r square h. We know the radius and the height. Now we can find the volume of water flows out. Volume of water flows out. That will be equal to volume of solid. Volume of solid means that is the combination of cone and hemisphere. So volume of solid is equal to volume of cone plus volume of hemisphere, which is equal to 1 by 3 pi r square h plus 2 by 3 pi r cube. Here also we know the height of the cylinder and the radius of, height of the cone and radius of cone, and we know the radius of hemisphere. We want to actually find the volume of water left in the cylinder. So volume of water left in the cylinder is equal to volume of cylinder or volume of water in the cylindrical vessel minus volume of water flows out. So we can write volume of water left in the cylindrical vessel which is equal to volume of cylinder, that is the total volume. Volume of cylinder minus volume of water flows out. That means will be equal to the volume of solid. So volume of cylinder minus volume of solid. So altogether we can write it. Volume of cylinder is pi r square h minus volume of solid we find out, that is 1 by 3 pi r square h plus 2 by 3 pi r cube, which is equal to pi r square h minus, open the bracket, so minus 1 by 3 pi r square h, negative into positive is negative 2 by 3 pi r cube. Now we know that the radius is same in all these three cases, so we can take the common factors out. Pi is common and the radius is common, so here r square is there, here also r square, you can take pi r square out. Then here height of the cylinder minus 1 by 3 pi r square we taken out, then 1 by 3 h. This h is the height of the cone, minus 2 by 3 pi r square is taken, so 2 by 3 r. Now we can substitute the values, you will get the volume of water left in the cylindrical vessel. Dear students, according to the new revised syllabus of CBSE, combination of 3 solids will not ask, but they will ask the combination of 2 solids. Here we are considering with the 3 solids, one cone, a hemisphere and a cylinder. Instead of that, they can ask a spherical shape or any other shape. Only 2 combinations they can ask. Look at the next question. A vessel is in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. According to the question, the conical vessel is filled with full of water up to the brim. So the volume of cone will be equal to the volume of water in the cone. We know that the radius of the cone is given and height of the cone also given. So volume of cone, that will be equal to volume of water in the cone. That is equal to 1 by 3 pi r square h. And it's given for you some lead shots. We don't know the number of lead shots. The spherical lead shots are put it in this vessel. That time some amount of water is flows out. That how much amount that is given for you. The 1/4 of the total volume, that much water will be water flows out. So volume of water flows out. Volume of water flows out equal to 1/4 of the volume of water in the cone. 1/4 of the volume of cone, or 1/4 of the volume of water in the cone. That will be equal to 1 by 4 into volume of cone is 1 by 3 pi r square h. And we know that there are n number of lead shots. We don't know how much it is. The volume of n number of lead shots, that will be equal to the volume of water flows out. The volume of n number of lead shots will be equal to the volume of water flows out. So volume of n number of n spherical, you can write n spherical lead shots is equal to volume of water flows out. Which is equal to 1 by 4. Volume of water flows out, that will be equal to 1/4 of the total volume. That means 1 by 4 3 are 1 by 12 pi r square h. We need to find the number of lead shots. So what will be the volume of one lead shot? First of all, we want to find the volume of one lead shot. That into n, that will be equal to the volume of water flows out. So volume of one lead shot, volume of one lead shot, that is in the shape of sphere. So volume of sphere is 4 by 3 pi r cube. Volume of lead shot, volume of one lead shot is equal to 4 by 3 pi r cube. Therefore, the number of lead shot is equal to number of lead shot. It's representing by the letter small letter n. So number of lead shots n is equal to volume of n spherical lead shots is equal to volume of water flows out. Volume of one lead shot is equal to this much. Then volume number of lead shots will be equal to volume of water flows out. Volume of water flows out divided by volume of one lead shot. Because there are number of lead shots are there, that is represented by let the number of lead shots be n. Then n into volume of one lead shot, that will be equal to the volume of water flows out. So n is equal to volume of water flows out divided by volume of lead shot, which is equal to, we know that volume of water flows out, that will be equal to 1 by 12 pi r square h. 1 by 12 pi r square h all divided by volume of one lead shot, that will be equal to 4 by 3 pi r cube. You can cancel the common factors. Pi you can cancel it. So 1 by 12 into This is the radius of cone and height of the cone. So radius of cone is given for you 5. So it will be 5 into 5 into height is 8 centimeter divided by 4 by 3 into r cube. Radius of a spherical lead shot, that is equal to radius of spherical lead shot is equal to 0.5. That we can write it in the fraction form, that it will be 5 by 10. The lowest form is 1 by 2. So we can take that radius is equal to 1 by 2 whole cube. That is 1 by 2 into 1 by 2 into 1 by 2. Now you can cancel the common factors. Here 4 is the common factor. 2 4s are 8. 3 4s are 12. So 5 into 5 into 2 by 3. So 25 into 2, 50 by 3. 50 by 3 all divided by 4 and 4 cancelled. 1 by 6, which is equal to 50 by 3 into 6 by 1. 2 3s are 6. 50 into 2, that is equal to 100. So the number of lead shots is equal to 100. So dear students, you should study these problems and you should note down these questions in your notebook. Today's your worksheet is exercise 13.2, question number 6 and 8. And you should write and study this exercise 2 times in your rough book and send that to my WhatsApp. So practice it well. Revise this all exercise 13.1 and 13.2. Questions in exercise 13.2 you should write it 2 times and you should send it to me and study properly. Thank you.